ಸ್ವಲ್ಪ ಸಾಕು, ಜಾಸ್ತಿ ಬೇಡ, ಸ್ವಲ್ಪ ಸಾಕು. ಜಾಸ್ತಿ ಇದೆ ಅಂದರೆ ಮತ್ತೆ ಅದು ಸ್ಪಿಲ್ ಆಗುತ್ತಲ್ಲ. In the given diagram, position of the null point is at the midpoint of A and B. Is at the midpoint of A and B. Now the resistance R is shunted. Now the resistance R is shunted by 10 ohms. R is shunted. What is the meaning of shunted? Parallel resistance is connected. Shunted by 10 ohms and null point shift by 20 centimeters. Null point shift by 20 centimeters towards left. Towards left. 20 centimeters towards the left. Then find the value of shunted resistance. Find the value of shunted resistance. What is the shunted resistance here? R. Shunt resistance is 10 ohms is given. Shunted nothing but for whichever the resistor you are doing the shunt, that is the shunted resistance. R value you have to find out. Find the R value. Forty by 3 is your answer. You got that? Yes, very good, Vaishnav, very good. 40 by 3 is the correct answer. ಏನು ಶ್ರೇಯಸ್ ನಿಮಗೆ 3/40 ಬಂತಾ? 40 ಓನ್ಲಿ 40ನಾ? ಮತ್ತು 3 ಎಲ್ಲಿ ಹೋಗಿದೆ? ನಿಮಗೆ ಕೂಡ ಅಷ್ಟೇನಾ? 40 ಬಂದಿದೆನಾ? ನೋಡು, ಹಾಸ್ಟೆಲ್ಗೆ ಬಂದಿದೆ ಅಂದರೆ ಅಟ್ಲೀಸ್ಟ್ ಹಾಫ್ ಆನ್ಸರನ್ನು ಬರ್ತಾಯಿದೆ ನಿಮಗೆ. No, he is behaving like a mad fellow only, na? In hostel. Whose room yaar? Shamant room. Okay, jodi ಚೆನ್ನಾಗಿತ್ತು. Oh, Instagram illala. I think you are becoming mad. Forty by 3 is the answer. See that here. First of all, they have not given any R, they have not even given the X also. But what they are saying, it is balancing exactly at the midpoint of A and B. Midpoint nothing but at what length? 50 centimeters. 50 centimeters and then remaining length also how much? 50 only. Without shunt resistance. So, only R and X is there. R and X is there. At that time, R by X is equals to how much? You will get nothing but 50 by 50. Exactly at the midpoint of AB they are saying. So that here, this will be how much here? R is equals to how much I can write? X. Now this is the initial case is finished. And after that they are saying that now this R is shunted by a resistance. Let me take that is a RS resistance. I have taken RS resistance is a shunt resistance. Whenever it is shunted, at that time they are saying that the balancing point is shifting 20 centimeters towards left. Understanding or not? It is shifting by 20 centimeters towards the left. Now tell me what is the length here? L is equals to how much? 30, right? Before it was how much? 50. Now it is shifting by 20, nothing but L is equals to 30. Then remaining length is equals to how much here? 70 centimeters is the 100 minus L value. Now you take the formula again. Let me take after shunting, we are getting the net resistance as R dash. R dash by X is equals to how much ratio is? 30 by 100 minus L is how much? 70. 3 by 7. Now what is this R dash now? R dash is equals to total resistance, net resistance, right? What is that? R into RS by R plus RS. So that here R into RS is how much I am saying here? 10 ohms now I have given, that is 10 ohms. So that R into 10 by R plus 10, that divided by X is equals to how much here? 3 by 7. You are understanding the problem, right? Before connecting the shunt resistance, exactly midpoint is the balancing point. After connecting the shunt resistance, the balancing point is shifted by 20 centimeters towards the left side. Then our initial length is, balancing length is 30, and then 100 minus L is how much? Obviously 70 only. Now the resistance has changed. How much it is changed? Nothing but R dash. R dash value is how much? Along with the shunt resistance, that is R into RS by R plus RS. That is what I have taken here. R into 10 by R plus 10 divided by, again right gap what is there? X only is there. So that divided by X, that is equals to 3 by 7. In the place of X, what I can write simply? R. X is equals to R, right? Before only for us. Now R is equals to R, and then R gets cancelled. Then what will get here? R is equals to exactly 40 by 3 ohms. You understand, right? How many of you got the same answer? Only 3 members, that's it. In the entire class. 4. Good, good. Next problem. A galvanometer having a resistance of 8 ohms. Galvanometer. No. Wait. Meter bridge, no. In a meter bridge, the balancing length. In a meter bridge, the balancing length from left when a standard resistance of 1 ohm is in the right gap, 1 ohm is in the right gap, is found to be 20 centimeters, then find the value of unknown resistance. You should not take this much time. What is the answer? 4. 4 is the correct answer. 4 or 1 by 4? 1 by 4. 1 by 4 is the correct answer. Check properly. 1 by 4 is the correct answer. That is just easy problem only. 0.25. Balancing length means always you have to take from the left only. But what may they mention here? From the left only they mentioned also. From the left how much they are saying? 20. Yes? 0.25 or 1 by 4 is the correct answer for that. Yes, you got that? How many of you got that answer? That's very easy. Yes, very good, very good. Next is potentiometer. Potentiometer. What is the purpose of potentiometer? In the name itself it is there. To measure the potential difference potential difference across any wire. You have to take the potentiometer wire will take. So that might be any wire, you have to find out the potential difference, not only wire, any device that might be, but the potentiometer is used to measure the potential. But why we are having voltmeter also, right? What is that? Without any error? No. It will not draw any current. Potentiometer will draw very less current as compared to the voltmeter. Why? Because this voltmeter, ammeter and then galvanometer, everything will be based on the moving coil galvanometer concept, nothing but based on the magnetic effect of the current. Everything will be based on the magnetic effect only. But here potentiometer will not depends on the magnetism. In that magnetic effect means in that torque will be there. Due to the torque only the coil will be turning, at that time only you will get the current effect there. So you might be remember that tau is directly proportional to theta we will take. So tau is equal to c theta, like that we will take. So by taking the theta value, again theta is directly proportional to I we will take. So NBIA, torque is equals to NBIA. Do you remember that formula? Yes, NBIA will be there. N is the number of turns, B is the magnetic field, I is the current, and then A is the area of the coil. I is equal to tau is equal to NBIA, torque is equal to NBIA will be there. So that in the same way, here based on the torque only the current will be produced there, and then by using that current only we will read the voltage and then even the current in the galvanometer, otherwise ammeter also. But here the potentiometer will not depends on the magnetism effect and all. So directly it will read the values by the length of the wire only. And also there and here, why we are having already voltmeter, why to use the potentiometer means potentiometer will not draw any current. It will not waste the current. But in the galvanometer, to rotate the coil it needs some current. By taking the current it will operate voltmeter. In the case of potentiometer it will not take any current. So whichever is using less current, that is only advantage for you. Yes, we are not wasting any current means that is advantage for us. So that only potentiometer will be preferred over the voltmeter. And also for the potentiometer there will be a concept that is sensitivity. So sensitivity nothing but the accurate value reading without any errors. That will be more for the potentiometer as compared to the voltmeter. What is the sensitivity? What is the formula of sensitivity? That we will discuss. Sensitivity nothing but it will give the accurate value without giving any error as compared to the voltmeter. Even in this also, in any device errors will be there, that is common. But as compared to the voltmeter, comparatively this one is better than the voltmeter. Main purpose is, one is it will not draw any current, it will draw the less current as compared to the voltmeter, and also it will have high sensitivity as compared to the voltmeter. So only we will prefer potentiometer over the voltmeter to measure the potential across any terminals of any object that might be, any component. You understand, right, why we use the potentiometer instead of voltmeter. Now here in this potentiometer there will be a principle. What is that principle? Nothing but the potential difference is always directly proportional to the balancing length. So that we will take as V is directly proportional to L. Balancing length means here I have the potentiometer like this, operating EMF is E here, and the internal resistance R, a switch is there here, and then here a series resistance, otherwise we call it as rheostat. Sometimes we call it as rheostat, otherwise series resistance. Rheostat also otherwise series resistance, everything is just variable resistance only. You might be done in the practicals also, by just moving the jockey we will vary the resistance of the rheostats. So here this is a rheostat, otherwise they will say it as a series resistance, anything is correct only. Now this entire setup is connected to a wire. This is the potentiometer wire of length L. It is not about very smaller values, it is not about 1 meter like that, it will be there 10 meters also, even 100 meters also it will be there. So as I increase the length at that time, its sensitivity also increases. So that potentiometer wire of length L we will consider L, and then this is having the resistance of how much? Nothing but R. Obviously wire means what it will have? Resistance it will be there. Why? Because it is having the length L. Obviously we will take a metal wire only of resistivity rho, let us consider, and then area of cross section is A. Then resistance is equals to what I can say? R is equals to rho L by A. Now in that I will connect one more battery here to just operate the galvanometer. Galvanometer is there here. Now this galvanometer, I am moving on the potentiometer wire. Whenever I move on the potentiometer wire at some point of length, let me take the length L, small l, then it is showing the zero deflection. Zero deflection means what I can say, it is balanced, null deflection. At that time, this is the balancing length. I have connected, this is known as a primary circuit, this is known as a secondary circuit here. In the secondary circuit, always will connect the galvanometer. In primary circuit, driving cells will be there. So here E is the driving cell of internal resistance R, and then rheostat is how much here? RS is the internal resistance. Then here the wire of resistance, how much is there here? Capital R is there, whose length is how much here? L. Whenever I move the jockey on this wire, at that time it is showing the balancing point at some length L. Now this length is always directly depends on the potential. Actually potential depends on the length. Whenever my balancing length is coming here, let us consider, if I connect one more cell here, I got a balancing length here. Then what happens? V1 is greater, V2 is greater. Initially, whenever this one is there, battery E1 is there, at that time I am getting the length here, balancing length. Next second time, I just remove this one and then I replaced by another one. Then again I am moving, I got somewhere here balancing point. So which is greater here? E2 is greater. Why? Because I said that potential is directly proportional to the length. If a length is increasing, nothing but what happens? Potential also increases only. So which length this one is? Total length or otherwise balancing length? Balancing length. Total length is capital L here. Clear? Now this is the principle of potentiometer. Whenever I remove the proportionality here, I will get a constant phi. So V is equals to phi into L. So phi is equals to what I can write here? Phi is equals to what I can write? V by L. What is the V by L means? V by L means what? Potential gradient. It is here, there is no charge is moving. If the charge is moving, at that time it will provide the electric field, that and all is different story. Now here V by L, anything by length, nothing but what is that? Potential gradient. So that this is the potential gradient. And that potential gradient also derivation is different, that will solve however. But mainly you have to understand that here potentiometer principle is always the potential across the wire is directly proportional to the balancing length. If the balancing length is increased, means automatically potential also increases only. Now I said one more concept, that is sensitivity. Sensitivity. What I said, sensitivity nothing but sensitivity is just what a reciprocal of the potential gradient only. Sensitivity nothing but the reciprocal of potential gradient. Now here sensitivity is equals to 1 by phi nothing but what is the formula? V by L. Then what will get here? L by V. The sensitivity is nothing but L by V. Now S is directly proportional to L here. S is directly proportional to L. Of course V also directly proportional to L only. Now S is directly proportional to L. Whenever I increase the length, then what happens? Sensitivity also increases. Sensitivity also increases. Then if it more sensitivity is there, nothing but that is more advantageous for us. So that only in the potentiometer wire we will use the long wire. The wire of the potentiometer, the wire of the meter bridge is only how much? 1 meter. But in the case of potentiometer it is very long. Why we are using that much long? Nothing but it will give more sensitivity. More sensitivity nothing but it will give the more accurate value. Clear? That is about sensitivity. Sensitivity is equals to 1 by potential gradient. That is L by V. We will get both are directly proportional to each other. If I increase the length here, then sensitivity also increases. That is one of the advantage for us. So only potentiometer wire will have more length as compared to the meter bridge wire. Clear? So if I increase more length of the wire, at that time it will give more accurate value. Clear? That is about the potentiometer. First of all write that potentiometer. Use it to measure the potential. Use it to measure the potential. Potentiometer preferred over voltmeter over voltmeter because what is the reason? It will draws less current as compared to the voltmeter. It draws less current while operating as compared to the voltmeter. And sensitivity of potentiometer is higher than voltmeter. Sensitivity of potentiometer is higher than voltmeter. Next one is principle of potentiometer. Principle of potentiometer. Like that, the potential across any wire is directly proportional to balancing length of the wire. Directly proportional to balancing length of the wire. Write that potential gradient, you copy along with the diagram. Oh, washroom करता है ना. హలో మేడం, డివిఎస్ది కలిసింది ఆల్రెడీ. ಹೌದಾ, ಸರಿ ಸರಿ. ಸರಿ. ಸರ್ ಹೇಳ್ರಿ ಸರ್. ಏನು ಕಳಿಸ್ಬೇಕು? ಕೊರಿಯರ? ಡೆಲಿವರಿ ಕೊಟ್ಟಿದ್ರಲ್ಲ ಆಲ್ರೆಡಿ. ಕೋಡಾ? ಓಕೆ, ಲೈನಲ್ಲಿ. ಹಲೋ, 464672. Finished? Next, sensitivity. Not a Colgate sensitivity. మీ టూత్పేస్ట్లో ఉప్పు ఉందా? Sensitivity. The reciprocal of ಏನಾಯ್ತಾ ಉಪ್ಪು? ಅವ್ರು ಕೇಳ್ತಾ ಇದ್ರ ಅದೇ ಉಪ್ಪು ಅಂದರೆ ಏನು? ಕನ್ನಡದಲ್ಲಿ ಕೂಡ ಉಪ್ಪೇ ಅಲ್ಲ, ತೆಲುಗುದಲ್ಲಿ ಉಪ್ಪೇ. ನಾನು ತೆಲುಗುದಲ್ಲೇ ಹೇಳಿದ್ದೀನಿ ಇವಾಗೆ. ಉಪ್ಪೇನಾ? ಉಪ್ಪೇನ ಮೂವಿ ನೋಡಿದ್ರೆ ಯಾರನ್ನ? ಉಪ್ಪೇನ ಮೂವಿ ಐ ಲೆಫ್ಟ್ ವಿತಿನ್ half an hour only. That much of matured movie we cannot see. ಯಾರು ನೋಡಿದ್ರು? Anybody seen that? Nobody. Raise ma. Before you raise your hand, now you are just getting down. How childish movie that is. What is that? The reciprocal of. The reciprocal of potential gradient. The reciprocal of potential gradient is sensitivity. Is sensitivity. As the length of the wire, increases, as the length of the wire increases, then sensitivity also increases. Copy that formulas. ಹರ್ಷ ಮಲಗಿದ್ರು ಏನೋ ವಾಶ್ರೂಮಲ್ಲಿ. ಅವಾಗ ಹೋಗಿದ್ದಾನೆ, ಬಂದಿಲ್ಲ ಅವರು. Determining potential gradient. Determining potential gradient. Determining potential gradient. Now you have to find out the potential gradient across the wire. For that you have to find out V by L. V by which L? Small L or capital L? Small L. What is the small L here? Balancing length. Capital L is total length of the potentiometer wire. Now here you have to find out the potential gradient. Before that we will take that as potential is equals to, what is the formula for us? I into R only. Yes sir, in this only current is flowing. In the potentiometer wire only current is flowing, and then the potential is how much? Nothing but between this point and then this point the potential difference is V and then 0. That is V. Now you have to find out that V by L. For that purpose I have taken V is equals to I into R formula here. R is what here? Resistance of the wire, and then I is the current flow in that. Now I have to find out that I first. Before that I have to find out the I. How to get the I? See that I is flowing in this circuit only. Who is giving the I? Nothing but the battery is giving the I, and then you have to apply the KVL here. Yes sir. So whenever I apply the KVL from this point, let us consider I have started here. Before that I got a resistance. Whenever I got the resistance, what will you get here? Minus I into R, and then I have gone here, I got the series resistance R rheostat. So how much again? That much is minus I into RS, and then again which one came? Internal resistance. So again how much? That is minus I into small r, then minus to plus E is equals to how much? 0, reaching the same point again. So here I have started, and then I got the resistance first. Current is flowing as I minus IR minus IRS minus I into smaller, and then lower potential to higher potential. So that is plus E, reaching the same point again 0. And then what is this one here? Switch. That is a switch key. Now here I is common. I will take I as common. R plus RS plus small r is equals to E. Then I is equals to E by R plus RS plus small r. This is the current value we got. The net EMF by net current, net resistance only, however. Now in that again you have to substitute in this formula. Then V is equals to, in the place of I can write as E by R plus RS plus small r into, what is the resistance here? Capital R is the resistance. Now I got the potential, but I have to get the potential gradient. For that what you have to do? Divide by L. So this L is which length? Nothing but balancing length. This resistance is for smaller value of length, otherwise total length. Resistance is for the total length, so that resistance out of the total length you have to take. Divide by L, divide by L. But this length is which length here? Balancing length. This length is the potentiometer wire length. Why we have taken so like that means, here we are getting the potential over how much length? Only small length, L only balancing length. Here why we have taken the capital L means the resistance we are having for how much length? Total length. So that only I have taken, that is V by L is equals to E by R plus RS plus R into R by L. Here what is R here? Capital R is nothing but Resistance of which one? Potentiometer wire. RS nothing but rheostat, otherwise series resistance. Small r is the internal resistance of the cell, and then R by L is the resistance per length, resistance out of the total length of the wire. Sometimes they will tell that they will not mention this R and L, directly they will give like this 100 ohm per meter. Ohm per meter nothing but what? Ohm is the resistance divided by the length. So that 100 ohm per meter nothing but indirectly they have given the R by L value. Clear? Now this one is nothing but again what I can write? Phi. Phi is equals to E by R plus RS plus R into R by L. This is the formula of potential gradient. Clear? Important formula. Only 3 formulas will be there. 4 formulas will be there. All are important. Once you learn the 4 formulas means you can do any problem based on the potentiometer. Clear? Let's copy that. ಅವ್ರು ಹೋಗಿ ಮಲಗಿದ್ದಾರೆ ಕಂಪಲ್ಸರಿ. ಹೋಗಿ ಪಿಲ್ಸಿರಪ್ಪ. ಇಲ್ಲಿ ಎಲ್ಲ ಶಾಡೋ ಇರುತ್ತೆ, ಸ್ವಲ್ಪ ಗಾಳಿ ಎಲ್ಲ ಚೆನ್ನಾಗಿ ಬರುತ್ತೆ. Write that where small l is balancing length. Small l is, write that now, as per now you can remember that. Later on if you open the book you cannot remember anything. Write that so only. Small l is balancing length. Capital L is total length of the potentiometer wire. Total length of the potentiometer wire. Missing ಸತ್ತೋಗಿದ್ರೇನು? ನಿದ್ದೆ ಜಾಸ್ತಿ ಬರ್ತಾ ಇದೆ, ಫಿಸಿಕ್ಸ್ ಕ್ಲಾಸ್ ಕೇಳಕ್ಕೆ ಆಗ್ತಾ ಇಲ್ಲ, ನೀವು ಸೂಸೈಡ್ ಮಾಡ್ಕೊಂಡಿದ್ರೇನು? ಹಾಸ್ಟೆಲ್ಗೆ ವಾ, ವಾಟ್ ಎ ಕಂಫರ್ಟ್, ವಾಟ್ ಎ ಕಂಫರ್ಟ್. Capital L is the total length of the potentiometer wire. Capital R is capital R resistance of the wire. Capital R is resistance of the wire. You know. Then RS is series resistance. Series resistance or rheostat. ಏನು ಹರ್ಷ ನಿಮ್ಗೆ ಹೇಳಿ ಹೋಗಿದ್ರೆ ಅವರು? ಏನಂದ್ರೆ ಇವರು? ನೀವು ಕೂಡ ಹೋಗ್ಬೇಕಾ? ಓಕೆ, ಇಬ್ರಿಗೆ ಏನೋ ಕೆಲಸ ಇದೆ ಹಾಸ್ಟೆಲಲ್ಲಿ. ಇಲ್ಲ, ಅವರು ಹೋಗಿ ನಾನು ಹೋಗ್ತೀನಿ ಫಸ್ಟು ಒಂದು 5 ನಿಮಿಷ ಬಿಟ್ಟು ನೀವು ಬಾ, ಕಂಪಲ್ಸರಿ ಬರಬೇಕು ನೀವು, ಇಲ್ಲಾಂದರೆ ಮಿಸ್ ಆಗ್ತೀನಿ ನಿಮ್ಗೆ ಏನಂದ್ರೇನು. Small r is internal resistance of the battery. Small r is the internal resistance of the battery. V is potential across the wire. V is potential across the wire. And E is EMF of the driving cell. What is PC there? Priyanka Chopra na? Primary circuit. What is the SC? Shreyas, Shreyas Kumar. Priyanka Chopra with Shreyas Kumar. Here this one J. Mick Jonas. Pramoda. Pramoda Shreyas. ಅವ್ರ ಎಲ್ಲ ಹೆಸರೆಲ್ಲ ಚೇಂಜ್ ಆಗಿದೆ ಅನಿಸುತ್ತೆ. ಇಬ್ಬರು ಕೂತ್ಕೊಂಡು ಫ್ರೆಂಡ್ಶಿಪ್ ಜಾಸ್ತಿ ಆಗಿ ಏನು ಪ್ರಮೋದ್ ಎಲ್ಲ ಚೇಂಜ್ ಮಾಡಿದ್ರ ಶ್ರೇಯಸ್ ನಿಮಗೆ? Next, determining the internal resistance of the cell. Determining internal resistance of the cell. Determining internal resistance of the cell. Now here I said while teaching about the cells concept, I said that EMF. What is the EMF? Nothing but. I said the EMF. What is the EMF? Hey, electromagnetic abbreviation kelila nanu. What is the EMF? The potential drawn without any external resistance. Correct? Without any external equipment. If we draw the potential, nothing but. Otherwise, if you find the potential, that potential is EMF. I said only battery will be taken, and then if you measure the voltage only for the battery, at that time it will be EMF. Whenever you are measuring by connecting a one resistance, at that time it will be what? Voltage. You understand or not? EMF. While teaching about the cell, I said that EMF nothing but without any external circuit, otherwise external component, if we measure the voltage across the cell, that is the EMF. If we connect anything extra, at that time what it will become as voltage. And then I said charging and then discharging also. Whenever you take the charging case, at that time we got V is equals to more, V will be more otherwise lesser, more than EMF. V is equals to E plus IR, V is equals to E minus IR in the case of discharge. In the case of discharge means what? The battery is giving the current. In case of charge means battery is taking the current. So it is giving the current and then taking the current means something is connected to that. At that time what is coming for us? Voltage is coming. Without any external circuit, otherwise without any component, whatever the voltage is exist, without taking anything out, otherwise without giving anything in, whatever the voltage exists in the cell already, that is known as what here? EMF. Clear? Now in this circuit, particularly if you observe, here this is the driving cell, that one is not there now. You should consider only the secondary circuit. In secondary circuit, I have taken the cell of internal resistance R. Now that is connected to an external resistance capital R here, load resistance capital R. Now what I am doing nothing but, whenever I open the switch, at that time what will be there? EMF or voltage? EMF. Why? Because resistance is not connected. Whenever I open the switch, at that time, at this case exactly, resistance is not closed for this. Resistance is not connected. At that time what will draw from here? EMF only. Whenever I close the switch, at that time what will be there? Voltage will be there. Clear? So based on that only balancing length will changes. Once I open this, at that time I am getting the EMF. By using that EMF, what I will do nothing but I will just move this jockey on this one. So whenever I move this jockey, at that time I am getting the balancing length exactly at length L1, let us consider. Now after that I close the switch. Once I close the switch, what will get there? Voltage will get. Battery is discharging or otherwise charging? Discharging. From the battery, current will come and then passes through the resistor R. So the battery is giving the current nothing but what I can say, that is discharging. At discharging time, what happens? Potential will, the voltage will be lesser than the EMF. We already got that V is equals to, what is that? V is equals to E minus IR. By the way, that is not necessary for us. Now whenever I move the jockey again, how much length will be balanced? Nothing but L2 will be the balancing length. Whenever I open, at that time how much length is balancing length? L1. At that time what is there? Only EMF or voltage? EMF only. At that time we got the balancing length as L1. Once I close the switch, At that time again I am moving, at that time balancing length is how much? L2. And now what will be there? EMF or voltage? Voltage. Closing nothing but, once I close, this will give the current to the resistor, so that it is giving nothing but at that time voltage will be there. Now once I open, at that time nobody is taking the current out from the cell, so that only it will be, what will be there? EMF will be there. Clear? Now whenever I have opened the switch, at that time E is directly proportional to L1. Can I say like that? What is the potentiometer principle? The potential is directly proportional to the length of the balancing point only. So here, whenever I open the switch, at that time my potential is EMF. So that EMF is balancing at what length I said? L1 length. So that only E is directly proportional to L1. Then I can simply say E is equals to X into L1. Then once we close the switch, at that time immediately what will be there? Voltage will be there. Instead of E, what will get? V we will get. Voltage V we will get. So once I close the switch, at that time current is passing through the resistor, so that instead of EMF we will get the voltage. So that at that time the potentiometer wire is balancing at what length? Length L2. Now that I can write as V is equals to how much? X into L2. You just keep it aside, divide them and then keep that equation aside. E by V is equals to what we can say? L1 by L2. That one is finished. Now what you have to determine, by the way, here? Internal resistance. Internal resistance nothing but this small r value you have to determine. To determine that small r value, first of all I have to find out the potential at these points. Through the resistor only you have to find out the potential. So this is a parallel combination here, whatever the potential is there, here also same potential only. Yes sir. Now I want to get that potential nothing but, I will take this as point A and then point B. I will start my journey at B. Why? Because the current is flowing in this direction. Now I am coming in this direction. Now VB first, then what will I get? Starting at point B, minus I into R, then lower potential to higher potential, plus E is equals to where you are reaching? A, so that VA. Clear? Now VA minus VB is equals to what I can say? E minus IR. That is what I said here. This is discharging, right? So only we got E minus IR. If it is charging means what will we get? E plus IR will get. You understand, right? Now this is the potential difference whichever we got. V is equals to E minus IR. Now I have which ratio here? E by V ratio. I want to get the R value. For that purpose, so here V is equals to E minus IR, and then IR is equals to what I can write? E minus V. And then I want to get the E by V. Then what I can do here? I can take the V common, otherwise what we can do here? E by V minus 1, correct? Is that correct? Then that is equals to I into R. I want to calculate the R value only. For that R value, R is equals to V by I into E by V minus 1. What is the V by I? Nothing but R only. Which R here? Which resistance? Capital R, nothing but that is not about the wire. Here there is no current flow. Where the current flow is there? In the resistance current flow is there. In the load resistance only current flow is there. So that this is the R here. Capital R is the resistance whichever we connected. You understand why I have considered this one? The current V and then I. Where is V? V is there across the resistor only. And then I is flowing only across the resistor here. We should not take the wire here. In wire nothing is flowing. I said already only secondary circuit should be considered here. Clear? Now here V by I nothing but the resistance R into E by V minus 1. This is the R value. This is also one of the formula whenever they have given the EMFs and then potential. Then even if you substitute here, then R is equals to what I can write? R into E by V nothing but what I can write here? L1 by L2 minus 1. Then one more is, if I still minimize this, R into L1 minus L2 by L2. What is this L1 first of all? Balancing point when it is switch is open. At that time what is coming here? EMF is there. Whenever the switch is closed, at that time balancing point is which one? L2. At that time what is there for us? Voltage is there. Listen again once more. So here I have connected the battery of EMF E and then internal resistance R. I have to mean potentiometer is not only applicable for the potential measurement. You can even use for the resistance determination also. You can determine the resistance also. Any cell you have connected and then you have to find out the internal resistance, means again you have to use the potentiometer only. For that I have taken the cell of EMF E, internal resistance R, and then after that a switch is there. So that switch is connected to an external resistance capital R here. Everything is going on in the secondary circuit only. Nothing is there in the wire and then in the primary circuit. So here what I did, nothing but I opened the switch. Once whenever I open the switch, at that time what happening, nothing but EMF is drawing in the cell. Why? Because there is no other components are there. So that EMF is directly proportional to L1. What is the L1 here? Balancing point whenever the switch is open. Whenever the switch is closed, at that time the resistance is drawing the current from the cell. At that time what will be there? Voltage will be there. That voltage I have to take it as V. At that time balancing point is how much here? L2. I just divided them and then I got some ratio here. You just keep it aside. Now here the battery is discharging. Battery is discharging, nothing but the potential across the battery is how much? E minus IR only. So E minus IR I have to write as it is. If you don't know that formula, if you don't remember that formula, you have to do like this. Otherwise directly if you know already that formula, means no need to do A to B and then B to A and all. Clear? Now V is equals to E minus IR because the battery is getting discharged here. Then this is what V we got. From that I have to find out the internal resistance R. For that I have taken IR here and then R again, taken V out, and then this is important here, V by I. V by I nothing but the voltage divided by the current. Voltage is across which one here? Across the resistance R only. Current is passing through what here? Resistance R only again. So V by I gives you, here voltage is point A, means here also how much? Point A only. Here point B means this is also how much? B only. VA minus VB is again how much? V only, right here. So that V by I is equals to R here. R is nothing but the resistance whichever we connected here. That into E by V minus 1. This is also one of the formula whenever they have given the EMF and then voltage. They have not given the EMFs, they have given the lengths, balancing lengths. At that time instead of E by V what I can substitute? L1 by L2. Clear? That is about the internal resistance, Yuraja. Yes, is that internal resistance? Right. Copy that. Malkandilla, but you are ready to sleep. Girls are safe. Why? Because I will not look much in this side. Specs iruttella avaru innu safe avaru. Amma Yashashwini? More advantage for Yashashwini only. Nivedita know that. Correct, Nivedita? Determining the internal resistance. Redraw the circuit again. ಏನು ಸರ್ಕ್ಯೂಟ್ ಡ್ರಾ ಮಾಡಿದ್ರೆ ನೀವು ಮಾಡಿದೀವ ಸಾಕೋಣ ಅಂತ ಇದು ಕರೆಕ್ಟೇನಾ? ಲೇಜಿಯೆಸ್ಟ್ ಫೆಲೋ ಇನ್ ದ ಕ್ಲಾಸ್ ಯಾರಂದರೆ ಅವರೇ. ಏನು PCSC ಫಿನಿಶ್ಡಾ? ಅಲ್ಲಿ ಎಲ್ಲ ನೋಡ್ತಾ ಏನು ನಿಮಗೆ ಅಂದೆ ನಾನು. ಪ್ರಿಯಾಂಕಾ ಚೋಪ್ರಾ ಅಂದೆ, ನಾನು ಪ್ರಮೋದ್ ಚೋಪ್ರಾ ಅಂದೆ, ಶ್ರೇಯಸ್ ಚೋಪ್ರಾ. ಇನ್ನು ಮಿಡಿಲಿ ಯಾರನ್ನ ಇರಬೇಕು, ಮಿಕ್ ಜೋನಾಸ್. ಪ್ರಿಯಾಂಕಾ ಚೋಪ್ರಾ ಹಸ್ಬೆಂಡ್ ರೀ ಜೋನಾಸ್. ಏನು ಪ್ರಿಯಾಂಕಾ ಚೋಪ್ರಾನೇ ಗೊತ್ತಿಲ್ಲ ನಿಮಗೆ? ಏನಂತ ಪ್ರಿಯಾಂಕಾ ಚೋಪ್ರಾ ಗೊತ್ತಿಲ್ಲ? ರಿಯಲಿ? ಯು ಡಿಡ್ ನಾಟ್ ಇವನ್ ನೋ ಪ್ರಿಯಾಂಕಾ ಚೋಪ್ರಾ ರೇ? ಫಿಲ್ಮ್ ನೋಡಿದ್ಯಾ? ಬರ್ಫಿ ಮೂವಿ ನೋಡಿದ್ಯಾ? ಅದರಲ್ಲಿ ತುಂಬ ಚೆನ್ನಾಗಿರ್ತಾರೆ ಅವರು. In South Indian films, she acted only one Telugu movie, that's it. Janji, that is a flop, utter flop movie. ಏನು ಮೂವಿ ಹೇಳ್ಬೇಕು ನಿಮಗೆ? ಅಷ್ಟು ಫೇಮಸ್ ಮೂವಿ. ಕ್ರಿಶಾ? ಕೊಯ್ ಮಿಲ್ ಗಯನಾ? ನಾ ಅವ್ರಿಗೇನ ಐಟಮ್ ಸಾಂಗ್ ಹೇಳ್ಬೇಕು, ಅವಾಗ ಗೊತ್ತಾಗುತ್ತೆ. ಫಿನಿಶ್ಡಾ? ರಾಮ್ ಚಾಹೆ ಲೀಲಾ ಚಾಹೆ ಅಂತಾರಲ್ಲ ಅವರೇ. Only he likes only Srivalli song, that's it. A great dance. ಗೌತಮ್ ಫೇವ್ರೇಟಾ? ಸ್ವಾಮಿ ಸ್ಟೆಪ್ ಗೌತಮ್ ಫೇವ್ರೇಟು, ಶ್ರೀವಲ್ಲಿ ಸ್ಟೆಪ್ ಇವ್ರಿಗೆ ಫೇವ್ರೇಟ್. ಇಬ್ರು ಸೇರಿ ಮಾಡ್ಕೊರಿ. Right, comparison of EMFs, last one. We'll close by this. Very good. ಪಕ್ಕನೇ ನಿಮ್ಮ ಶ್ರೀವಲ್ಲಿ ಇದೆ ಅಲ್ಲ, ಅದಕ್ಕನೇ ನಿಮಗೆ ಪಕ್ಕನ ಸ್ವಾಮಿ ಇದ್ದಾರಾ? ಯಾರು ಸ್ವಾಮಿ, ಯಾರು ಶ್ರೀವಲ್ಲಿ? ಗೌತಮೇ ಸ್ವಾಮಿನ? ಮನೆಯಲ್ಲಿ ತುಂಬ ಜನ ಇದ್ದಾರಲ್ಲ. ಸೊ ಹಿಯರ್ I have taken two cells here of negligible internal resistance, and then these cells are connected to a switch here. One switch is there for the upper cell, and then another switch is there for the lower cell, and then here galvanometer is connected. Now what happens means, whenever I close the first switch, then which is operating here? First EMF only, right? Second one is open, it is not connected to anybody here. Second one is open. Whenever I close the first switch, at that time E1 is operating. E1 is operating, and then I move it on the wire. At that time what I can say, it is balancing at length L1, let us consider. Now again in the second case, what I done, nothing but I have just opened it and then closed the second one. Then which EMF is operating here? Second cell is operating, so that E2 is balancing at length L2. Now I can say this one is E1 is equals to XL1, and then here E2 is equals to again XL2. Then whenever I just divide them, what I can write here? E1 by E2 is equals to L1 by L2. Which combination of cells here? Parallel combination. And also one more formula will be there for the series combination also. I will tell you that on the next class. Why? Because for that class also I stopped here only. So we will start together. Now this is just comparison of EMFs whenever they have connected in the parallel combination. In series, one more formula will be there, that is E1 by E2 is equals to L1 plus L2 by L1 minus L2 will be there. That we will discuss in the next class. So here I have taken two cells of EMFs E1 and then E2. Once I close the switch K1, at that time E1 is operating, giving the balancing at what length? L1 length, and then I open the K1 and then close the K2. At that time who is operating here? E2 is operating, giving the length is at what length? L2, balancing at length L2. Now whenever I divide them, we got E1 by E2 is equal to simply L1 by L2. Then you have to compare that EMFs here. E1 is how many times of E2, otherwise E2 is how many times of E1. Clear? Just copy that. Observe.